cutting-edge lasers, razor-sharp robotics, and fabrication finesse.
You good? All right.
Inspired by a race car, built by an automotive legend.
Best thing you can do is just hold on. It's fast, it's nimble, it's balanced, and it just does everything you'd ever expect out of a sports car.
500 horsepower, pushing 320 kilometers an hour. To build this American sports car, you need the Corvette Superfactory in Bowling Green, Kentucky. Sleek, streamlined, super cool. From its checkered flag to its 4 famous taillights, it's a legendary icon. For 50 years, the Vet's defined the American sports car. Classic, coveted, unmistakable.
It's like a thoroughbred. It's like riding Secretariat. The engine can move the car with such ease that you just press on the gas just a little bit and the car just flies away.
Now, this car colossus is breaking all the rules. Meet the revolutionary Z06 in pure speed and horsepower. This 52,000 euro Corvette rivals exotic foreign cars like the Ferrari F430 and the Lamborghini Gallardo. So light, this grand touring mega machine handles like a race car. So powerful, it goes from 0 to 96 in 3.7 seconds. So fast, it pushes over 320 kilometers an hour. All backed by a custom Corvette engine on steroids.
When you push that pedal on the right, that car accelerates like no other car in the world.
There's only one place on Earth where this monster machine can come together. The Corvette Superfactory in Bowling Green, Kentucky. In this 92,900 square meter superstructure, a build team of nearly 1,200 workers assembles each Z06 in the car track, paint shop, trim, chassis, and testing areas.
A lot of times it seems like the ants are scrambling all over the place and everybody's going 100 different ways. When you really start getting down on it, everybody has a mission.
But to build one of these speed demons from the ground up, it takes 2 more phenomenal facilities. One's near Motor City, Detroit, where they put together the powerhouse engine. The other one's over 100 kilometers away in Hopkinsville, Kentucky. This is where the Z06's story really starts. Before you can build it, you've got to frame it. For a chassis frame worthy of a Z06, Chevy hired the ultimate chassis manufacturer, Dana Technologies. The goal? Keep Corvette's classic design while pushing it to record-breaking top speeds, faster than ever before. But with these unique frames, size matters. The Z06's frame must be the exact same size as a regular Vette, and for good reason. Both have to fit on the same assembly line at the Corvette factory in Bowling Green. If it's off, it'll ruin the entire production line.
The biggest challenge that we had was this frame has to flow seamlessly into the Bowling Green operation where the steel frame and all the other Corvettes are made.
For engineers, it was a tough challenge. Lighten the Z06's load without compromising quality. Their solution? A thick aluminum skeleton called a space frame. Durable, moldable, and lightweight. While a standard Corvette's space frame's made from steel, the Z06's aluminum frame's 30% lighter, shedding an incredible 136 pounds. And lighter equals faster.
We've replaced the entire structure with aluminum. And to our knowledge, in all of the automotive history, no other manufacturer has ever done a steel version and aluminum version of basically the same car.
The major components of the all-aluminum space frame are 2 side rails, the front and rear bumpers, the roof bow, and the drivetrain tunnel. To produce a sturdy frame, all the individual parts need to range in thickness from 1 to 5 millimeters. The space frame starts in a machine called a Genesis cell. It's a robotic welder that welds brackets and other hardware to the side rails. Later, the axles, suspension, and engine will be attached there. The external skeleton of the space frame is formed when side rails are welded to the bumpers. This requires a MIG weld. It's stronger than a regular weld, and workers have to do it by hand. In MIG welding, high voltage electricity melts a welding wire inside the gun. To protect the weld from outside contaminants, the gun also emits a shielding gas. Done correctly, a MIG weld is clean, bright, with even overlapping scales, and it provides a stronger bond to the finished weld. Now it's time to assemble the center of the space frame. The center's made up of two critical parts. One's the drivetrain tunnel, and the other's a tube called the torque tube. The torque tube transmits power from the transmission to the engine. For a road-hugging, low-riding Corvette, it's a vital component, shielding the driver from noise and bumps. Hitting the button puts a robot to work that laser welds all the pieces of the drivetrain tunnel in 20 minutes. The laser welds do more than just hold the pieces together. They completely seal gaps in the metal to help keep road noise and water out of the cabin. Now that the drivetrain tunnel assembly's finished, it's time to weld it into the space frame itself. After that, technicians weld on the roof bow, which holds the fixed roof and front and rear windshields in place. They also install lock and hinge pillars to support the doors. To hold parts of the space frame together, workers use over 200 self-piercing rivets, or SPRs. They're not only rigid, but they add strength to the overall structure. The rivet pierces through the space frame, locking into the aluminum. The top of the rivet flattens out, making a button shape.
Unlike a normal rivet where you have to pre-drill the hole, it will actually pierce through the top material itself.
The welds and rivets are now in place. But to be Corvette factory ready, the space frame needs a few more steps: trimming, grinding, and drilling. Amazingly, all the steps are done by the same machine, powered by a computer numerical controller, or CNC. The CNC tells the blade how to cut, sending it specific data in the form of numbers. These numbers direct the cutter several ways and even control the depth of the incision.
This is the largest machining center that I personally have seen. You would not see anywhere else except at Dana an entire frame put inside a machining center at one time.
First, the CNC grinds and trims the Z06 frame, making sure it fits the standard Corvette shape. The difference can come down to mere millimeters. The machine trims down the surface within 1/4 millimeter of the standard Corvette steel frame. Later, at the Bowling Green factory, this will allow the Z06 to share the Corvette assembly line with the Corvette coupe and convertible. Next, the CNC drills holes, following a computerized template. These holes will ultimately fit bolts and screws needed in the assembly process. Picture it. The Z06 floor, dashboard, body panels, and powertrain will all attach to this skeleton. Next, an overhead conveyor carries the space frame to the inspection line for a thorough examination. The final step in the space frame build, inspection. Brent Grady has an eagle eye for perfection. So do two robots. They have 6 cameras that take photos and compare the images to pictures of a perfect space frame.
At this point, all the welds have been inspected. Everything from the front of the line to this point has been inspected. Now it's going to travel into the DVT for final inspection.
This is the frame's last stop before heading to the Bowling Green factory, so it's critical they catch any glitches here. So far, so good, until camera 6 lights up. It shows a failure. The machine's looking for the exact hole circled in the master sample. The cameras are so sensitive, if it's not a perfect picture, they send an alert. technician Brent Grady examines the drilled hole. It passes his inspection. The completed aluminum space frame has taken just 18 minutes to build. It weighs just under 130 kilograms, the lightest ever for a Corvette. Now, the space frames are shipped more than 100 kilometers east to Chevy's Corvette factory in Bowling Green, Kentucky. Here, the Z06 aluminum frames join regular Corvette steel frames being prepped for buildup at the factory's car track area. First, the frame gets a thorough cleaning. It's baptism into Bowling Green. The system cleans off all the oils and any other materials. Then the frame takes a dip in a protective process called electrodeposition, where it gets a coat of black paint to prevent any rust. High voltage power in the tank attracts the paint to the aluminum frame, giving it a sturdy seal to keep out the elements. Now it's ready to be suited up with all the customized Z06 parts. Once the space frame dries, a robot applies adhesive and attaches the rear trunk tub to the frame. Most sports cars have minimal trunk space, but the Corvette will have a massive trunk, over a half a cubic meter of storage space, one of the largest available in a sports car. Next, a robot attaches the Z06 flooring to the frame. But these are no ordinary floors. They're made of a carbon fiber skin with a tough balsa wood core to absorb road noise and provide rigidity. Combined, they weigh 2 kilograms less than the standard fiberglass and balsa wood Corvette floorboards, reducing the weight by 30%. And on the Z06, every kilogram saved translates into more speed and power. One of the last steps in prepping the space frame for assembly is installing the dashboard. It all happens at the dashboard sub-assembly area. Workers wire up the dash. The finished dash then travels to the car track area, where it's attached to the space frame. With the dashboard secured, the Corvette factory in Bowling Green, Kentucky has made the space frame ready to assemble into a Z06. But so far, it's just the skeleton of the powerhouse. America's love affair with Corvette began in 1953, when designer Harley Earl and General Motors introduced their two-seat sports car. They dreamed of one that would rival those in Europe. But it was 1955 when Ed Cole, chief engineer for Chevrolet, introduced the small block V8 engine. That marked a turning point in Corvette history. There was no other small block like it, lightweight, robust, and powerful. It became the choice for GM's performance car market and cars on the race circuit. 50 years and 90+ million engines later, his engine design still thrives and rules the road.
If you look at the auto industry and look at how long vehicles have been produced, well, Corvette is a survivor.
$1.4 million Corvettes later, the Corvette remains America's first American sports car. The reason? The Corvette has never changed its tune, churning out top speeds, a sleek body, and raw horsepower. And those who drive them, they're in a league of their own.
If they're not a superhero in their own lives, or maybe they're not a great athlete, they buy a sports car and all of a sudden they're sort of the best athlete on the road.
I admire Ferraris, but I can have 3 Z06s instead of 1 Ferrari. I'm gonna change my Z06 every day.
Now that skeleton is ready for some skin. The body panels that give the Corvette its unmistakable look. Most cars have raw metal body panels added before the car is painted. But the Corvette's body panels aren't steel. They're lightweight fiberglass.
We want to make the car as light as possible so the response time is very quick. One way that we do that, of course, is with the aluminum frame, and another way that we're able to accomplish is with the panel.
The Corvette's body panels are painted before they're put on the car in the factory's paint shop. The paint process will take 10 hours and involve 3 coats of paint: primer, color, and top coat. Ultimately, the panels will emerge in 8 bold colors. First, they're loaded on the conveyor. Then they get a thorough once-over by a paint inspector. Any defects in the panels get kicked back.
I'm looking for pits, orange peel, any defects that might cause a problem once it gets back into prime. We try to catch our problems if we have any before they go to the next station. You gotta check them 100%. You never know when that one's gonna make it through, and that ain't good.
One of the biggest obstacles to a flawless finish, contaminants brought into the paint shop by people who work here. Before entering, workers wash their hands to remove any dirt and oils that could leave fingerprints. Next, the crater test. Tiny loose particles or fibers that people shed all the time could cause a big problem for the Z06 finish. They can show up as craters or small shallow indentations on the paint. Every paint worker is tested for any contaminants. If they're a risk, these craters show up beforehand on a test panel. Silicone is the #1 crater causer. Silicone is in a lot of personal hygiene products that people use every day, like deodorant, hair products, or fabric softener. First, workers rub a panel against their suit and shake their sleeves over it. Any particles that fall out could contaminate the paint. Next, the panel's sprayed to see if anything shows up.
We're going to have to go ahead and place this panel up here and spray it out now and check for craters.
Then it's placed in an oven for 20 minutes to bake out any traces of contaminants. If any craters show up on the panel, it means no entry for a paint shop worker. If the panel fails the test, this is what it will look like. These splotches are craters, and they'll completely ruin a Z06 paint job. This panel passes, so the worker goes through an air shower to blow off any other dust particles. And then finally into the paint shop. Inside, the first step for the raw fiberglass panels is a thorough washing and dusting. The idea is to create a clean, smooth surface that becomes the foundation for a flawless paint finish. Then the panels go into the primer booth for a smooth base coat foundation that will allow the paint to grip better. 4 robots apply a micro-thin layer using air-atomized spray guns. The guns expel compressed air, breaking the primer into droplets, propelling the paint to the body panels.
We found that you cannot do an equivalent paint job by hand that you can do robotically. They do a great job. You put a panel in, and it does a consistent paint job better than most people can do by hand.
Now the panels are ready for some color. The Corvette factory has 2 paint lines, each painting a different color every day. The paint shop colors nearly 320 panels per hour, using over 250 liters of paint to keep up with the pace. 4 robots spray the panels with 2 coats in total, reaching 5/1000th of a millimeter in thickness. Next, the final paint layer, the urethane clear coat. The urethane forms a tough shell to protect the paint from the elements. A specially crafted machine coats the panels evenly. The paint electrically charges to the panel in a computerized pattern. The bell spins using 60 kilovolts. It breaks up the paint into very fine droplets, evenly spreading them over the panel. Now it's time to make sure the paint job's perfect. Every customer wants a Z06 with a flawless finish. The paint shop finesse deck is where final paint flaws are identified and fixed. Even with all these precautions, sometimes blemishes appear. Black marks indicate any and all flaws. Workers circle them and then get to work, bringing them back to perfection. A worker uses fine sandpaper and deionized water to rub off the mark. He uses a swirling motion to avoid scratching the surface. Once it's out, it's buffed and polished in a checkerboard motion for a perfect shine. Once the body panels pass their paint inspection, it's time to install them onto the space frame in the factory's trim area. The Z06 now begins to take shape. First, the rear quarter side panels go on using 11 screws. Then the classic backside of the Z06, the rear fascia, goes on. Technicians connect the wires and bolt the panel to the frame in 10 locations. The front fenders attach after the Z06 engine's in place inside the engine compartment. Next, it's time for seats with smarts. These electrical car seats are actually equipped with computers. David Kearns installs a special child safety device that's linked directly to airbags. The computer's so sensitive, it can tell whether an adult or a child sitting in the seat. It's a life-saving precaution.
There's a scale in the seat. I'm plugging that up. It's like a child safety device to where if the kid's under 80 pounds, the airbag will stay off, but if they're over 80 pounds, it'll come on. Then I hook up the power supply right here in the front.
The installation of the power seats completes the classic cockpit interior of the Z06. With the seats installed, it's time to hang the doors. The Z06 door panel travels to a separate sub-assembly where they receive the glass inserts. At the trim line, technicians use special hoist for heavy lifting, anchoring and aligning the doors.
We are installing the door onto the car. Found a fixed position here. I got the pin that goes into that hole here, which is a very critical part. And after I have the door set, I just install my bolts. I'm inserting 4 bolts into the A-post. That takes 8 bolts. I'm doing an initial torque out, kind of serves like a clamp. And then right now I'm doing my final torques.
Next up, installing the classic teardrop rear window. The teardrop rear window has been a distinctive Corvette feature since 1963. The reason for it goes beyond cosmetic appeal. It's actually functional. Corvette designers initially believed the teardrop shape would be more aerodynamic. In later years, advanced aerodynamic tools like wind tunnels and computer-aided design proved the engineers were right. Today, more than 40 years after the first rear teardrop window was put on a Corvette, brand new Z06s get a similar treatment.
You can look back in Corvette history. It turns out that that particular element of the aerodynamics of the 63 car is still proving to be an excellent aerodynamic solution today.
Installing the teardrop window demands extreme precision. Even more critical is the next step, sealing it with urethane and letting it set for 4 hours, safeguarding a solid fit. Kevin Kilpatrick keeps an eye on every detail.
I line it up over here. We set it right down in there like that. Then we knock it down. Got it. Put our tape up there so it won't slide down. When we come up into the top like this, knock it down and be sure that it's even all the way around.
At last, the signature window's secure. The Z06 has now gone as far as it can in the assembly process without a powertrain. The engine, transmission, and all the gearing that sends power to the wheels. Now it's time to build the most powerful engine ever put in a GM passenger car. It's hard to comprehend just how powerful the 7-liter LS7 V8 engine is. The standard Corvette has 400 horses, and the Corvette Z06, an earth-shattering 505 horsepower. That's so much thunder that a race-tuned version of the same engine gets dropped in the C6R race car and powers it to Le Mans victories. The engine thrusts the Z06 from 0 to 96 in 3.7 seconds, and that's without leaving first gear. Make your way through all the gears, ideally on a closed track, and you can hit nearly 320 kilometers an hour. You'd think this cheetah of the road would be a pig on gas, but somehow it gets 10 kilometers per liter on the highway.
Almost everything is unique about the LS7 engine in the Z06. Everything about the way it breathes, the way the air flows through the engine, the size of the valves, the material used, it's extremely efficient, and it's really the heart of the Z06.
The 7-liter LS7 engine essentially is a large, high-tech version of a classic Chevy V8, as it's been made for more than 50 years. The engine block houses 8 pistons that move up and down to turn the crankshaft. The crankshaft turns the prop shaft inside the torque tube that will eventually bring power to the wheels. What makes the pistons move? Ignited fuel and air. Fuel and air enters through the intake manifold. Then valves in the cylinder heads let in the fuel and air mixture. Spark plugs set off an explosion and the piston snaps downward. Another valve lets the exhaust out, and the process repeats itself thousands of times every minute the engine runs. But where the LS7's engine is different is in size and weight. Big engines are usually heavy, but the LS7 engine uses a lightweight aluminum engine block, 45 kilograms lighter than a standard iron block engine. And key parts inside the engine are made of super strong but ultra lightweight and expensive titanium. A lighter engine means it can use its power to make the car go faster instead of pushing its own weight. The Superfactory that builds the LS7 engine is GM's Performance Center in Wixom, Michigan. Most modern engines are put together on an assembly line, but not the LS7. It's hand-built like a race car engine by one technician who hand-assembles it. A turntable device helps with the monster engine assembly. The operator uses a wheel to rotate the engine base, while different components are added on. Greg Jones is one of these highly trained technicians. He begins with the crankshaft and lowers it into the block.
Now I'm going to put the crank in and the main caps back on with the bearings, lock it all down. We got the cam in, it'll be ready to go.
The crankshaft is key to engine operation. It moves in a circular motion and makes the pistons go up and down, powering the massive Z06.
And that gives you your power to go. And this is the heart of the engine. The crank is the heart. So now I'm going to put it together, and then we'll go put the pistons in.
Next, the forged steel main bearing caps hold the crankshaft in. This keeps it rotating and running smoothly. The bearings and caps get torqued by a special computer-controlled wrench. It handles the heavy work and provides spot-on tightening accuracy. A green light means it's done right. Next up, 8 flat-top aluminum pistons that will endure thousands of cylinder explosions every minute while turning the crankshaft. The rods and bearings connect the pistons to the crankshaft. They're made of expensive titanium, which is both incredibly strong and lightweight. Before the pistons go in, they're lubricated so they won't scratch the cylinders. Then they're fed into the block through a ring compressing funnel. To secure each rod and piston assembly, Greg uses a special electric fastening tool. He repeats the process 8 times, 1 for each cylinder rod. The computer double checks to make sure they're completely tight. Next, Greg secures the cylinder heads.
This is the cylinder head of the Z06, and here's the intake and exhaust portals right there.
These heads hold the valves that let in fuel and air and let exhaust out. A 15-socket computer-controlled machine bolts the cylinder heads to the engine. The cylinder heads have to be huge to meet the engine's high airflow demands. The Z06's engine allows 25% more airflow than any other Corvette. That extra airflow equals faster combustion and tremendous power.
The combustion of the engine is right here, the valve train, the exhaust, the intake, burns the gas, the air mixed, it's all right here. You gotta have this. The engine's not gonna work unless you have these 2 heads on here.
The engine inhales all of that air and fuel through a critical part called the intake manifold.
Now we're ready for the intake, and the intake's what pulls the air into the fuel, and the engine itself has to have air. And that's what runs your engine,
and we're going to put that on right now.
The intake manifold supplies the air-fuel mixture to the cylinders.
So this is when it starts looking like an engine. So this is one of the most important things of the engine.
It takes 20 torques to tighten this intake manifold to the engine. This torquing sequence could make or break the entire build.
You got to torque it in the right order, or you might get some kind of upheaval or something like that. So, and the order is middle to out, just like we've done the whole process here. This engine takes 324 torques, and 20 of them's right here. I mean, this, like I said, this is a big part of the engine.
It takes 4 hours to hand build this engine from crankshaft to manifold. For Greg, putting it together is a work of pride. Like an artist who signs each piece, Greg's about to put his stamp on this Z06 engine.
And they see our name and they know how special this is because no other engine in General Motors does this. Just the Z06. This is the most important part of the engine right here. When we put our name on it, because we know we did a good job.
And when he sees a Z06 out on the open road, he wonders whose name's under the hood.
I want to stop and look at the name and see who built it all the time. I just like to know, did I build that one? I might have built that engine, Barcode right here.
That custom craftsmanship shows when the engine starts up for the first time. It passes all its diagnostic tests. At last, it's ready to join a Corvette Z06 in the making. Back at Corvette Assembly Central in Bowling Green, Kentucky, as soon as the Z06 engine arrives at the chassis area, workers get ready to assemble and install the critical component called the powertrain, the engine, transmission, and torque tube. The Z06 is starting to come to life. First, workers connect the exhaust valves, hoses, downpipes, fuel, and gas lines to the engine. The Z06 engine looks, feels, and runs like a race car engine. It's no wonder. It was designed alongside the Corvette C6R, the most technically advanced race car Corvettes ever made. While developing the C6R race car, designers at Pratt & Miller Engineering in New Hudson, Michigan, worked hand-in-hand with Corvette engineers who were creating the Z06. This combined vision produced 2 world-class sports cars that share the Corvette look, design, and performance. The Z06 and C6R are designed for 2 different environments, but they share powerful and proven racing technologies. Their engines are virtually identical. The 7-liter V8 engine, titanium connecting rods, intake valves, crankshaft, aluminum cylinder heads, and aerodynamic tuning. They even share the same dry-sump oil system that prevents oil starvation on high G corners and under severe braking. For the C6R, engineers take technology one step further, using computer-aided designs and durable cutting-edge materials like lightweight carbon fiber parts.
You want to make parts as light as possible, but yet they have to last and all that that brings. The car goes through some severe punishment during that time.
Another huge consideration, designing a compatible airflow system in the C6R that would help it compete with the fastest cars on the track.
In racing, how the air passes through and over the car is very important. You want to reduce drag, balance downforce, and anywhere that the air goes is critical in a race car.
The solution? An aerodynamic design featuring a carbon fiber hood that allows for maximum air intake and a giant adjustable wing on the back.
As you can imagine, the car going 180 miles an hour and then you want to stop, the car naturally wants to pitch forward. With the air pushing down on the back of the car, it helps prevent that, and it really keeps the car planted to the ground.
On the outside, the C6R and the Z06 also share many of the same dimensions. They have nearly identical front body styling, teardrop back, and large tire openings.
We worked very closely with the design studio as they were working on the Z06, what they would like to see going towards that car, how to treat the radiuses around the tire openings. All those little things are very critical and can largely influence the airflow coming out from underneath the car or just how it flows over the surface. And we traded off and made some compromises but also helped lead the design a little bit to get better airflow for the street car as well.
It all adds up to a winning design. The C6R race car has placed in the top 5 for the last 5 years at Le Mans, France's most prestigious 24-hour sports car race. And in the American Le Mans circuit, it won the season championship for the last 6 years. For the street model Z06, that racing heritage shows in every detail. Here at the Corvette factory's drivetrain pit in Bowling Green, technicians finesse the powertrain installation. They've got to bring it all together: engine, transmission, and the all-important brakes and suspension system. To handle the 505 horsepower engine, the Z06 relies on one of the most sophisticated suspension and braking systems ever put into a Corvette. It all starts at the suspension sub-assembly station. The Z06 suspension installs on top of one of Corvette's most unique features: 2 long and flexible pieces of composite material called transverse leaf springs. These leaves form a double wishbone design across the front and rear of the car. The Z06 suspension's built onto the leaf spring foundation. To support front suspension, a technician attaches the front magnesium cradle, half shaft, and steering gear.
Right here is the steering gear for rack and pinion that goes on for the steering. Front cradle is made of magnesium for the weight distribution. This is a half shaft. It's a little heavier half shaft than our standard. It needs to be a little bit heavier for the torque that the Z06 puts out. Has one nut holding the half shaft in place.
The Corvette Z06 is one of the fastest cars you can buy. But with the need for speed comes the need to stop or slow down, and fast. That's where the Z06's monster brakes come in. They can take the Z06 from 96 kilometers an hour to a dead stop in just 33 meters. These hefty brakes work like clockwork. Here's how. On braking, caliper pads squeeze down on both sides of the wheel's rotor disc. This creates friction, slowing or stopping the wheel's motion. In the front axle, workers install huge 14-inch vented and cross-drilled front rotors. Holes in the rotor's surface allow the engine's gases to escape faster. This increases brake durability. And with 6 brake pads in the front, the Z06 has excellent braking power.
This is the front caliper. It has 6 different brake pads, 6 pistons. Gives you a little better stopping.
The rear brakes get 34-centimeter vented and cross-drilled rear rotors and 4 brake pads.
This is the Z06 knuckle. This the rear has 4 different pads, 4 pistons, drilled rotor.
At last, the Z06's brakes come together. The system's ready to join up with the rest of the powertrain. Now, all the pieces need to come together at the Corvette Factory Powertrain Hub. Get ready for souped-up suspension and transmission perfection. The powertrain is comprised of the engine, transmission, and everything else that helps transmit the engine's power to the car's wheels. In an ordinary car, an engine is directly attached to a front transmission. From there, a drive shaft takes the rotating energy from the transmission and transfers it to a part called a differential. But the Corvette Z06 is no ordinary car. It's one of the fastest sports cars in the world, and it must have world-class handling to match its world-class speed. One key to perfect handling: perfect weight distribution over the front and rear axles. The entire Corvette Z06 weighs less than 1,500 kilograms. The LS7 engine is also extremely lightweight, weighing little more than 200 kilograms. But in a featherweight car like the Corvette, it's still like a boat anchor weighing down the front of the car. A car heavy in the front will steer poorly and plow into turns, something you don't want in a sports car or a Le Mans racer.
We've really focused on taking the weight out of the Z06 on the front end. We don't want to take weight off the back end because those are the wheels that are powering the car, that are driving the car. So less weight there means less traction.
Chevy's solution? Move the heavy transmission to the back of the car to balance out the weight. But a rear transmission still needs to stay connected to the front engine. It takes a part called a torque tube. Here at the chassis area, the transmission and engine join together with a torque tube that's supersized for the job. The torque tube bolts directly into the engine, effectively transferring power to the transmission in the back of the Z06. At last, the most powerful engine ever put in a GM production car is now part of a complete powertrain. It's looking for a Corvette Z06 body to make it one of the fastest, lightest Corvettes ever built. The drivetrains are on the floor and the bodies float overhead. At the factory's chassis area, technicians install the distinctive stainless steel quad exhaust system. It's a preamble to what technicians call a marriage. A marriage between the powertrain and body. It's one of the biggest moments on the assembly floor. The space frame, including the body panels, seats, doors, and windows, meets the powertrain. This is where it officially becomes a Z06. Two conveyors merge into one. The body and powertrain are put together bottoms up. The powertrain is hydraulically lifted up and the body is lowered. They meet somewhere in the middle. Two teams of 4 technicians connect the body and powertrain at 30 attachment points. It's a challenging procedure, and a moving assembly line adds to the difficulty. Almost 3 minutes later, the marriage is over. The body and powertrain are one. Now, the Z06 is ready for one more race car addition, a dry-sump oil system. A typical car uses an oil pan to circulate oil throughout the engine, but the Z06 and the C6R race car use something different, a separate reservoir outside the engine that actually pumps oil through the engine.
This is a dry sump system for the Z06. It's the same system used in the C6R race car. It's got 2 hoses going to the motor that flows in and out, keeps the oil fresh and pumping.
There are 2 reasons for the special oil sump system. One is the Z06 is too low to the ground for a conventional oil pan. The other reason has to do with G's, or gravitational forces. During high-speed cornering, an average car will tip, sway, and swerve.
You go around corners, as you know, when you're in high center of gravity vehicles, the car tends to roll. The lower it is, the closer to the ground it is, the better the car handles.
In the Z06, the driver will experience lateral G-force that pulls the car sideways to the left and right. The Z06 is so well designed that it can still turn the corner hard and stay on the road with a sideways force of 1G.
At 1G, you have to hold on to the steering wheel and keep yourself planted in the seat, or you'll just slide right across the seat.
In this video-equipped test vehicle, the red water on the dash demonstrates the effects of G-forces as the car corners. The Z06 also has heads-up display that shows G-forces along with the car's speed.
You can watch the water move left and right, which is an indication of the forces, the side forces of lateral acceleration that we're generating. See, the water's starting to move now.
The same thing would be happening to oil in a conventional oil pan.
And we just go a little faster, faster, and we're just going to keep going faster until we get over 1G. All right, we're over 1.04, and the water's pretty far up, I can see that.
Oil would also be forced to the side of an oil pan, making it impossible to be moved up to the engine during a sustained period of cornering. The G-forces would starve the engine of oil, and it would break down from the heat. That's where a dry sump oil system comes in. Rather than being gravity-fed like an oil pan, the oil sump system consistently pumps oil through the engine, regardless of the G-forces the car's subjected to. Chevrolet's Superfactory in Bowling Green, Kentucky has just merged the Z06 Corvette body with its powertrain. It's almost an official road racer. The car's nearly finished, but still needs its tires and its final body panels, the fenders and hood. The standard Corvette would get front fenders made of super light fiberglass, like the rest of the body panels on the car. But the Z06 gets something different, something lifted right from the C6R Le Mans racing technology. The Z06's and C6R's fenders are made of something lighter than fiberglass, carbon fiber. Tightly woven, thread-like strands of pure carbon make up each carbon fiber fender. It weighs just 3 pounds, 80% less than a conventional steel fender. A key component of handling performance is the wheel and tire combination. The factory's trim area literally is where the rubber meets the road. The Z06 features Corvette's largest wheel and tire combination ever. The front 10-spoke wheels are 45 centimeters in diameter and 24 centimeters deep. The rear wheels are even larger, 48 centimeters in diameter and 30 centimeters deep. An air-lifted table glides the tire up to the assembly point like a giant air hockey puck. And a device called a Tommy gun torques bolts to the Z06 suspension. Goodyear developed these tires along with the Corvette race team.
The race team developed some proprietary internal technology internal to the sidewalls that actually helps the tire lean against a corner and keeps more of the tire flat on the road surface as you're going around the corner. More rubber on the road means more cornering power.
With the tires and wheels in place, the Corvette factory brings the car to life for the first time. The Z06 is almost ready, but it's got to face a critical final step. Before it hits the road, it hits the testing station. The dynamic vehicle test zeroes in on the wheel and tire pressure, checking how it handles at 112 kilometers per hour. This Z06 tests perfectly. From a bare aluminum space frame to a fully loaded chassis, the Z06 is now ready to leave the Corvette factory. But for professional drivers like Tom Wallace, the real test happens at Chevy's official proving grounds in Milford, Michigan. In addition to being an engineer, Tom's also a level 3 racer. But he insists anyone can handle the Z06 with the proper respect for what this car can do.
Okay, here we go. The idea is you go as fast as you can. We just go a little faster, faster.
Tom takes the Z06 around the challenging course. Even though it's pulling more than a G, it hugs the corner like it's competing at Le Mans. Tom bumps it up to 160 kilometers per hour, and the car barely breaks a sweat.
Driving a Z06 is actually unbelievable. It's very close to race cars that I've been in. I couldn't believe how much fun it was. It just does everything you'd ever expect out of a sports car.
The race car-inspired Corvette Z06 is unlike any other sports car on the road. The lightweight space frame and 505 horsepower engine are the essence of power, speed, and cutting-edge technology. This new generation sports car is the pinnacle of Corvette engineering and aerodynamics, and it can only be built by Corvette's best at the Corvette Superfactory.